So my name is Michel Viso. I'm currently the astrobiology program scientist at the French National Space Agency. And the topic of today is about protecting the bodies. It's just an introduction to planetary protection. I present that with inputs of colleagues from NASA, Catherine Conley, who is the planetary protection officer at there. Gerard Minek, who is playing the same role, almost the same role, I would say, at the European Space Agency, and with a contribution from John Rummel, who is the chair of the COSPAR panel on planetary protection, and will speak about that a little bit. And with André Debu, who is now, I would say, working in the ExoMars team at ESTEC, but he was formerly the CNES point of contact for planetary protection, and he did a lot of work here. So we will go through these different points: the legal basis, what is the COSPAR policy and what is COSPAR, implementation in the various agencies, the gold standard, and different views, and to finish by the conclusion, which is quite classic. If you have any question, you can ask me after or during, if you prefer. And if you have something in mind later, you can send me email, and I will try to answer with what I know. So the legal basis. So the first thing that you have, that we must have in mind, is that the world, by the beginning of the space era, was not the world that we are knowing now, and the world seen by this time was mainly two big blocks, let's say the capitalist block and the socialist block, and some of you know about that already, and some what we call non-aligned movements, countries from the non-aligned movement. And the treaty, which was prepared just after the first launch of the satellites, and which was signed in '67, was the direct outcome of this sharing of the world, let's say. The world now in 2013 is different, is a multilateral world, with a lot of countries, with a lot of interaction, the rise of new countries and the decline of others, and but we are still with the same treaty and with the same rules. The main basis, which is the main law or treaty which is ruling the space activities, is the Outer Space Treaty, which was put in force in 1967. The exact name is the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies. So, by the beginning of 2012, it was ratified by a little bit more than 100 countries and signed by 21 others. And the planetary protection, and this treaty is speaking about a lot of things, and let's say that the main goal is to keep weapons out of space and out of the celestial bodies. And it's ruling that you cannot, no country can take ownership of any piece of the celestial bodies. And in this treaty, there is a special Article 9, which is the basis, and which is recognized as the basis of the planetary protection. And you can read it: is state parties shall pursue studies of the outer space treaty, of the outer space, including the moon and other celestial bodies. That means it's everything in the solar system, and conduct exploration of them to avoid the harmful contamination of extraterrestrial bodies. Harmful, we don't know if it's for the body itself or for the people coming here. It's a way to avoid, I would say, contamination and to prevent future exploration by the other countries, and also adverse changes in the environment of Earth, resulting from the introduction of extraterrestrial matter, and when necessary to adopt appropriate measures for this purpose. So the goal is to protect either the bodies and the Earth. In 1979, there was a second treaty which was set for signature. This is the Moon Agreement. It was 10 years after the arrival of Neil Armstrong on the Moon. And but only a few countries ratified this treaty, only 13, and just 4 signatories. France, for information, is one of the 4 which signed this treaty. So this Article 7 is referring once again to the protection of the bodies and of the Earth with different words. And the goal is not to protect against harmful change in the environment of the bodies that we are visiting, but to prevent the disruption of the existing balance in its environment, which is a little bit more stringent. That means a small change cannot be admitted. And the same for the Earth with a small difference. So there was a few years ago an analysis of this treaty by the Institute for the Space Law and Telecommunication in France, and they made a lot of work. And so the main conclusion are that the Outer Space Treaty is recognized as a solid base for the activities in the outer space, and I would say a lot of contracts and agreement between the states are referring to this treaty. And the state parties include all spacefaring nations. State parties means that organizations are not part of the treaty. At the UN, it's an exchange, and the signature of the treaty are done by, I would say, a state. An organization like ESA, which is a supranational, cannot sign this treaty. It applies with a legal force to the state parties, and it's recognized as establishing a customary international law. And everybody agrees that even there is no penalties if you are not following the law. Everybody recognizes that this is a reference for the activities that we have in space. And the Article 9 is opening the door for a large discussion about harmful contamination, the 2 terms which are difficult to interpret. And in our case, which is considered here mainly as biological contamination, not chemical contamination, not nuclear contamination. And this leads to side effects that the celestial bodies are better protected than the Earth. The Earth adverse change is more general. So this treaty is signed, and COSPAR, which is a commentary for space research, took over to make recommendation about the planetary protection policy. So the COSPAR is a science union which is in relationship with the UN, but is just a science union. That means that there is rules of this, obviously, but people are there by themselves. The representation is made by the science academies, but they don't have a special mandate from their government. They are not representing their government when they are speaking or voting there. And this place is a widely open forum for all countries, and we have there open discussion with a strong presence, at least in the planetary protection, of ESA and NASA representative. I would say yes, European and US people, plus some Japanese, but we very seldomly see people from other faring nations like China, India, Japan, or Russia. So Russians are coming sometimes, but not very often. So, and COSPAR edited a planetary protection policy And you can go on the site of COSPAR and you will find this COSPAR Planetary Protection Policy, which is not a rule, not a law, not a regulation, but is a set of recommendations which are not binding, and they define, I would say, and classify all the activities that we can have beyond the low orbit or the low Earth orbit. And we will go quickly through these categories of mission. So the COSPAR Planetary Protection Policy set up, I would say, 5 types of mission, 1, 2, 3, 4. And the 5th is concerning the Earth return of samples here. And the classification, we will go on the next slide more in details. The first category is all type of mission. When we are speaking, the type of mission is either flyby, orbit, or contact with the body itself. Contact means contact with the atmosphere, or contact burning in the atmosphere, for instance, or contact with the soil itself, if there is any. That means that either landing or crashing. And we make the difference with some bodies like the Sun, obviously, Mercury, Venus, and some asteroids, that there is very few chance to change anything, and we must know simply the impact probability, and we have better to avoid, I would say, the contamination, and so it's not very requiring a lot. So other, like Venus, Saturn, Uranus, Neptune, and a lot, so you have to make a crash probability minimization and the passive control of the contamination. So if you don't want to crash, it's better to tell that you are taking some precaution. Now, Pluto and Charon are considered that as potentially able to change category. Then in category 3, you have, I would say, mission which are supposed to fly by or to orbit several bodies like Mars, Europa, which are of interest for astrobiology and for the search for life. And you have also some rules with minimization of the crash probability and active control of the contamination. That means that you must know how many germs, spores you are sending there on the surface or inside the spacecraft. The most active part, I would say, is when you are in contact with the ground of the atmosphere of place of interest like Mars. For Europa, you don't have a real atmosphere, so yeah, it means that you are crashing. And you have different categories which are taking in account, I would say, if there is an astrobiology payload or not. The goal is to avoid, I would say, false positive. You cannot claim that you have found life if you have found terrestrial life that you bring with you. And you see 4A, 4B, 4C. I will not go in details. There are a lot of discussion, and mainly about the special regions. And if you go on the Space Study Board site at the National Academy of Science of the United States, you will find a lot of booklets which are the results of analysis of these conditions, and you will find a lot of information about that. Let's say that right now, for instance, Mars Science Laboratory, or Curiosity, which landed on Mars the 6th of August last year, is classified as a 4B mission. It was supposed to be 4C mission, but because of after analysis of change in the design, they decided that it would be only 4B. That means that right now, if you want something very interesting in a place where you could have, let's say, the appearance of water, or if the temperature is rising up to 0 degree or something like that, you cannot go and you cannot make a drilling and you cannot make anything in this region. Be sure that if there is such an opportunity, there will be a committee to check if it's possible or not. The fifth, sorry. The fifth category is concerning only, I would say, the return to the Earth return of samples from space. And this is done, for instance, when you are recovering samples from a comet, from an asteroid, and if we are bringing back new samples from the Moon, from Mars, from Europa, and so on. So we have to make the difference between the forward contamination, that means contaminating the body that we are visiting, and the backward contamination. So I speak about that. And for instance, for the category 5, to classify a mission as restricted Earth return, that means that you have to make to take some precautions, and we will speak about it a little bit later. There is the Space Study Board proposed a series of 6 questions for each body that you want to sample, and you have to answer to this question. And they are based on what is the scientific evidence when, by the time of you are launching or when you are recovering the probe on Earth. So the one is to indicate if there was never liquid water in or around the target body. So this, for instance, a comet. There is no evidence that there was liquid water in or in the target body itself. The second one is indicate that metabolically useful energy sources were never present. If you go on a comet, it's difficult. If you cannot assume that there is no energy source, you don't know. But if you go on Mercury, for instance, you have a lot of chance to tell that there is no metabolic useful energy sources there. Indicate that there was never sufficient organic matter in or on the target body to support life. So if you, that's I would say you have to discuss that. What the presence of CO2 or carbonates. For instance, now we know that on Mars there was CO2 and carbonates. Indicate that subsequent to the disappearance of liquid water, the target body has been subject to extreme temperature, up to more than 160 degrees, for instance, which is a case of several places, but not for the satellites, for instance, from the outer planets. There was no sufficient radiation for biological sterilization of terrestrial life forms. That's another question that now people are able to answer by modeling and by modelization. And finally, indicate that there have been a natural influx to Earth via meteorites of material equivalent to a sample returned from the target body. I put material equivalent because, for instance, from Mars, we know that we received already several meteorites. And we know already more than 50 meteorites coming from Mars. We know people have collected already these kind of things. And so that means that there is no reason a priori to protect the Earth if we receive from something coming from Mars, because we received already several tons of material coming from Mars. All the subtlety is in the material equivalent, because if we are going to Mars, we will not bring back, I would say, basalts of some metamorphic or ultramafic rocks, and we will choose to retrieve mainly a kind of sedimentary deposit, if we could find some, to look for life or life form or something like that. And on Earth, we never saw and we never found any sedimentary rock coming from Mars for different reasons. Perhaps it was never the case, or perhaps if it was the case, it's very, very difficult to look at these rocks because they are quite fragile, and as soon as they are on the Earth, they are almost destroyed or similar to the rocks that we can find on Earth. So we cannot make the difference a priori between a rock from Mars in a field from a rock from Mars and a rock from the Earth. So this is, I would say, why material equivalence is very important. And this is the reason why we still have to take care of a sample coming from Mars. So the category 5, when you have the Earth return mission is classified restricted, when it is qualified non-restricted, you don't have to take any particular precaution, but to protect your samples. And this was the case, for instance, when with Genesis, a US mission which bring back, I would say, photons and atoms from the solar wind. This was the case with Stardust, which was classified as unrestricted Earth return, and people don't take any precaution to protect the Earth from life form which could be on the comet. It was the case also with Hayabusa when they retrieve the dust from the asteroid Itokawa. When you are in a restricted Earth return mission, you have a set of recommendations, and the first recommendation is about the outbound leg of the mission, which should meet the contamination control requirements of category 4B, and for C if you go in a special region. And when you are returning the sample, you can either use a sterilization process which is approved and accepted, and we don't know how to sterilize, I would say, life form that we don't know. Martian life form, if it exists, we don't know how we could sterilize it. It's 60 degrees, 200 degrees C, we don't know. And unless you are able to make something to sterilize these things, you have to use a sample container, which must be sealed after the acquisition, and it must be fail-safe about the containment, and you must be sure that there is no dust, and you have to break the chain of contact between the surface that you are visiting and the Earth. That means that you have to make operation to be sure that there is no dust and no small particles able to stay on the surface of which is in contact with the Earth's atmosphere. So this is the responsibility of the agency, and at each step of the flight, you must have reviews to decide a go or no go. And there is, I would say, 3 different stages. First, prior to launch. That means that prior to launch, you are sure that what you are doing is, as much as you know, in accordance with the recommendation of COSPAR and the rule of the agency, of each agency. The second is prior to leave the celestial body to return to Earth, you must be sure that you have everything in place and everything is able to work. And finally, prior to be committed to Earth re-entry, I would say just before coming to Earth, you have to be able to check the health of the system that you are working with, and to be sure that he will re-enter closed without any leak, and able to be retrieved without breaking anything. As soon as the unsterilized samples are returned to Earth, you must set up a program of life detection and biohazard, or to sterilize them. This is an absolute precondition before the release and the controlled distribution of any portion of the sample. This was stated by the Space Study Board in 1998. I remember that I work for CNES with NASA when we had in plan to make a US-French sample return from Mars, and we worked on a live detection and a biohazard testing protocol, which is still, I would say, a kind of reference. Even now, is changing and is improving as the time is going on. So this is, I would say, the general condition in which planetary protection is considered elsewhere, and we will see how it is implemented in the space agencies. So in the United States, I would say the planetary protection policy is part of the NASA policy directive, and it's referenced explicitly, and there is a reference to the Outer Space Treaty. There is a function of the Planetary Protection Officer who was reporting directly to the NASA administrator, and now recently the chain of command changed and is varying with time. I'm sorry for the H which is missing. And now is reporting, the Planetary Protection Officer is reporting to the head of the Planetary Division at NASA, a step under, I would say, and not directly to the NASA administrator. But in any case, the NASA administrator is in charge to ensure for the US government that everything is in accordance with the Outer Space Treaty and the COSPAR recommendation. At ESA, it's a little bit more difficult because ESA is not a country, and even ESA is bound with the treaty. And there is to think a planetary protection working group, gathering scientists and experts to advise the PB the HME Directorate, HME, and also now the Directorate for Science. And there is at ESA a planetary protection officer, Gerard Kminek, who is at DTEC, at the, let's say, the quality department of ESA, and is in charge to advise either the project and the general director about all the matter which is dealing with planetary protection, and is in charge of ensuring the compliance of the ESA mission with the COSPAR guidelines. In fine, if there are launch either in Guyana, that means in France, France will have, I would say, will set up, I would say, a planetary protection committee able to advise the French government, because in fine, this is the French government, if you are launching from Guyana, which is giving the authorization and which is in charge of certification. In the other countries, the situation is variable. I would say in Japan, I do not identify a specific position, but JAXA is reporting on a case-by-case basis, internally definitely, and to COSPAR and to the agency when they need some help. For instance, if JAXA or when JAXA needs the deep space network of NASA, NASA is asking JAXA to demonstrate that they are complying with the planetary protection recommendation of COSPAR. And they make a report, and they came back and telling that what they are doing. This was the case, for instance, when JAXA retrieved the Hayabusa mission samples, because they were arriving in Australia, in a park, in a natural park of Australia, and Australia asked COSPAR to certify that there was no risk. And I remember that we had a special session examining which was the target of the Hayabusa mission, how we can classify it, and we have to certify that this was not presenting any danger for Earth in general, and that JAXA take all the precaution with all the precaution required by the COSPAR. And on this, based on this recommendation or this advice, the Australian government authorized JAXA to retrieve on its territory their mission. In Russia, there is a special commission of the Science Academy, which is coordinated by a biologist of IMBP, and they are giving case by case an advice or a report about their activities. As far as I know, and it's difficult to know, but as far as I know, there is no continuous work or working group working on a continuous basis on this topic. In China, frankly speaking, I don't know, and in India, I don't know either. These two countries are relevant because they intend to send probes to the moon, which is not a problem right now, but they plan also to send a probe to Mars and also to other celestial bodies. And it would be of interest to have them concurring in this effort. Even they signed, both China and India, they signed already the Outer Space Treaty. So, let's say that for the agency, the Outer Space Treaty is binding the state parties, and by consequence, the international organization like the European Space Agency, even the final decision depends only about the launching state. The state parties are responsible of the activities done in and from their territory, as of the activities which are conducted by private entities of the state or by the nationality of people of this country or of this entity. That means that in any case which is private, public, from anywhere in the world, the country which is from which the people are coming from, the country is responsible of what is done. So this is a very, very strong responsibility for the countries. That means that you cannot tell, I am, I don't know, a French, I'm working in Nigeria, and I can do what I want with sending anything on Mars. You cannot do that, even it's difficult on a technical point of view, but legally you cannot do that. So this is, I would say, the treaty itself. COSPAR, the Committee for Space Research, is emitting only a recommendation which could be considered as a soft law. Soft law, that means that it's a law without any penalties if you don't follow it. But is a law that means that is a reference for most of the people. But right now, at least in between ESA, NASA, and Roscosmos, mainly, I would say the baseline for the planetary protection approach is based on the responsibility and a wide consensus. This consensus is important because, for instance, when you go to the COSPAR, the Committee for Space Research, and you are speaking about planetary protection, you are the people who are speaking and the people who are voting are the people who are in the room. I would say at COSPAR, you don't have a mandate, you don't have procuration, and if you have 10 people in the room, the 10 people in a public session may propose to the COSPAR a new regulation and things like that. So that means that it's not an agreement like a treaty at the UN, and is really a weak recommendation And this recommendation to be strong must be based on responsibility and consensus in between the main actors. So how was done the planetary protection? And there is a kind of gold standard, which is the Viking mission to Mars. Viking mission were two there were two missions which were launched in the 70s by the US, and these were the first landers on Mars, and they intend to investigate extant Martian life. And it was considered as a category 4B, which is absolutely normal. And they need to minimize the probability of contamination of the surface, and mainly to have false positive results because they would grow terrestrial bacteria or life forms. And the policy set up by NASA was done according with the COSPAR, and this recommendation included a clean room assembly, in a very clean things, and a bioburden, that means the diminution of the number of spores, reduction by dry heat sterilization of the entire spacecraft. Dry heat means that you are heating in a kind of without water and without water vapor. You are heating all the spacecraft. And from what they did and from what they measure, before the sterilization, there was around 300 spores per square meter, and a total of not so many spores, I would say, on the spacecraft. And after sterilization, by calculation, and they considered that there were only 30 spores on the entire spacecraft, which is very, very, very slow. I don't know in the world on Earth something which is as clean as this was Viking. So this was obtained by cleaning all the instruments and surfaces with IPA, isopropylic alcohol, placing the lander in a sealed, tight bioshield. That's something which is avoiding the recontamination after sterilization, and cooking the landers for 30 hours at, you see, 112 almost degrees C. So this is the gold standard, and even the walls are not done are done in copper and not in gold. I could say that the price was almost gold. The price tag was equivalent to a gold chamber like that. So this was done, and this is the only time the two landers were cooked. There was two Viking missions, and the two landers were cooked in this way. And they dismantled all this cooking pot, I would say, a few years ago at Kennedy Space Center. Right now, people are using different way and different means to ensure the planetary protection. And you can see the view of the engineers. In the bioburden levels have been obtained by the sterilization of each component using different way of sterilization, heat, chemical, radiation, isopropylic alcohol, and things like that. Then the sterile assembly in clean rooms could be class 100,000 or 1,000 or even better. Then cleaning the surface with wipes and isopropylic alcohol, and packing in a bioshield. For instance, there was a mission, Phoenix, which was supposed to dig in the soil, and it arrived as a 4A category, and the arm was specially sterilized for scooping and to reach the 4B level. And it was in a bioshield. And if you go on the NASA website of Phoenix, a mission which was 4 years ago, you will see the opening of the bioshield when it arrives, and leaving, I would say, the capability of the arm to reach and to dig in the soil and to make scooping in the soil. So it's difficult to ensure, I would say, sterility. You can see this, the assembly room of Sojourner, the first small robot rover which was on Mars. You can see here, I would say, a view of the arm and the assembly of Mars Science Laboratory at GPL. So you can see a lot of people, a big room, a lot of wires and articulations, and you have to be sure that this is sterile. And that means that you have to do a lot of tests. And for Mars Science Laboratory, I don't know how many hundreds of thousands of samples they did and analyzed to look at the number of the total spore and the total contamination of the system. Obviously, it's not absolutely sterile in the term that there is absolutely no spore, but the level of contamination is very low, and it's cleaner. It's cleaner than any, I would say, surgery room in the best hospital of the world. So it's very clean. So you can see the final assembly, and in this case also you have to ensure, and you can see the bioshield down, which will be just above when the assembly is finished. So, and you have to be sure that when you are on Mars, you are still clean and able to make analysis. You can dig, you can see on the left, you can see here, I would say the part where they dig, and the scoop was also specially protected. You can see the trace of the wheel, and the wheel were also specially protected before the launch and during the assembly, and so on, to be sure that there is no contamination. So from the engineers, planetary protection requirements could lead the mission to be category 4 and 5 and requiring a bioreduction. So that means that you have to choose the proper, it's almost finished, to choose the proper components able to resist, choose sterilization method that you want to apply at the end. This impacts the choice and the way of the components and the way you will make the integration and the test. And it impacts also the cost of the mission. So the planetary protection requires careful consideration very early in projects which are concerned, and taking into account the last experience from Mars Science Laboratory. That means also that the planetary protection must follow all the time, permanently, I would say, the project step by step. And the planetary protection people have to be informed of any change or any intention of change during the project. So, view from the scientists, and the scientists which are the most concerned about at least the forward contamination are the astrobiologists, because they are looking for life, extant or extinct life there. And the biological contamination could impair the scientific results, and which is of interest for everybody. The sensitivity of the instrument is dramatically increasing every year. That means that you must have not only, you must be clean on the biological point of view, but you must be clean also on a biochemical point of view, because now you are not looking for cultivation or growth of microbes, but you are looking for the chemistry, amino acids, carboxylic acids, and so on. And because now you have a very good sensitivity, you must be very clean. So before returning the sample, it will be almost impossible to distinguish, in any case, terrestrial contamination from the discovery of a possible extant Martian and perhaps sometimes a European life. This implies that a strict decontamination of the spacecraft and of this instrument is needed. And this is simple to tell, but it's not so simple to do and to perform. And now we have a lot of discussion which are still ongoing about the possibility for some terrestrial organism to multiply on Mars and to find an ecological niche in the possible ocean of Europa. And from the last discoveries, COSPAR people and NASA people and ESA people are thinking how to be sure that we are not taking any risk for the forward contamination to contaminate the body. From the management, so first, as an agency, planetary protection is mandatory because we are part of countries signatories or which have ratified the Outer Space Treaty. The PP, the planetary protection policy, is the charge of the agency. That's clear for everybody. And the government has to certify and authorize the launch, and we have to give the good advice to the government. The main problem could arise along the course of international missions. But now the planetary protection requirements are more and more stringent, and the missions are more and more ambitious, complex, and rare. That means that the costs are increasing dramatically. So just to finish quickly, there are new considerations about the icy moons, and you know that, for instance, ESA selected JUICE a few months ago, and this mission will make some flyby of Europas before going around Ganymede, and then to crash on Ganymede. That means that we have to go and we have to see what are the conditions to be sure that we are not contaminating these bodies. Even when you are doing a flyby around Europa, you can miss your flyby and you can crash on Europa, which is something critical. So, from the recent knowledge, we can see that we discover, not every day, but very often, new organisms, microbes, archaeans, which are supposed to be adapted to a strange and stringent environment. You know that we found some archaeans which are able to grow, and the best temperature to grow is around 113 degrees centigrade, which is quite a lot. Some others are able to live in a very salty or acidic or basic environment, and so the range in which life is possible is increasing regularly on Earth. That means that the range in which we can find life is increasing elsewhere, and means also that if we send such organisms in a planet or on a bodies, they could find, I would say, a place where they could grow. So Mars is, in any case, the main subject for exploration, and we are since a long time preparing a possible Mars sample return. There are a lot of discussion about the discussion of spatial region, and you can go on the SSB site, Space Study Board site from the National Academy of Science. Even, as I told, we had Martian meteorites. There is a consensus to consider that any return sample from Mars will give a mission restricted Earth return. And a joint work is ongoing to refine the treatment of these return Martian samples. And for instance, the last issue of the last booklet was issued by the European Science Foundation and ESSC, European Space Science Committee, and you have here's the site and the reference to retrieve the booklets on PDF. It's very interesting, and it's giving advice. Is quite general, I would say, but it's very informative for newcomers. So this is almost my last slide. So COSPAR is maintaining a planetary protection policy since almost 40 years. The general categorization can be assessed from the scientific goals, the experiment, and the target body. You see that you have 3 pillars on which you are doing a categorization. The planetary protection requirement must be considered as soon as possible in the development of a project. This is my personal recommendation, and I think that all the planetary protection officers agree on that. We have to adapt the measures that we are preconizing with the available knowledge, and you know that about Mars, about the icy moons, about several bodies, the knowledge is changing and improving quickly. That means that nothing is frozen. And in fact, each mission is evaluated on a case-by-case basis, and we have to make a review of what we know and what we fear. So let's say that the basic principle is that the pristine celestial bodies are a mankind asset, and planetary protection is a way to conduct sounding research and exploration in the future, not to impair the future for the future generation. And early cooperation on planetary protection issues will build up a wide consensus protecting this asset for the future generation. So just I borrow a cartoon from John Rummel, telling that science class should not end in a tragedy, and I think that everybody is agreeing with that. So thank you for your attention, and I'm ready to answer any question, if I can.
I'm just kneeling down so you can see me from the TV. I have a couple of questions. Do you have any comments on the level of planetary protection on the Cassini-Haynes mission, particularly the Haynes spacecraft that landed on Titan? Would we do it differently now than we did it the first time? And then a second question, there has been recently lots of talking about mining on asteroids and the moon. Do you have any comments on this?
About Cassini-Huygens, I would say that people took several protection, but you know that people went on a place that nobody has any idea how it could be, and so there was some supposition, and they took some precaution, and obviously, and as I told, as the knowledge is improving, new measures and will take place to protect the planets. That's and we will not do now as we are doing now. We have done. We will not do now how we have done in the past. But the available techniques for sterilization are improving too. And for instance, we have the use of oxygen peroxide vapors or things like that, which was not used by this time, I would say. Considering the second question, I think that it's not really a planetary protection issue. It's a real issue with the Outer Space Treaty, because the Outer Space Treaty preclude any ownership of any celestial bodies. That means that mining is not possible right now, according with the Outer Space Treaty. And I'm sure that there will be a lot of discussion before this could be done. Right now, I would say using, the famous helium-3 from the moon. I don't know if there is any, but if there is any, and if people want to use it for a private goal, it's not possible. You are authorized by the Moon Treaty to use, I would say, the body, the celestial body, to survive or to live there, and to get out from this this thing. That means that you could mine Mars to retrieve the iron and to set up your rocket and to come back to Earth. So we have time to do that, but I would say on a legal point of view, this is possible. But to mine something and to bring it back to Earth, this is supposed not to be possible.
Okay, then one more question. Do you have any comments on human exploration of Mars? That must be quite a problem for planetary protection.
Definitely, yes. We don't see any way to have exploration of and human exploration without I would say a contamination of the body. The COSPAR policy, first, the Outer Space Treaty is very general and is speaking about, I would say, is not giving any time, any end to the exploration or something like that. In the COSPAR, initially, because it is a scientific body, the planetary protection was understood as a way to avoid any false positive in the search for extraterrestrial life on the body that we are visiting. And for instance, the probability to avoid a crash is around 50 years, and people were considering that the exploration will last around 50 years or 1 century. But as soon as you will have people there, you will have a contamination. And I think that everybody almost agree with that. Right now, there is the beginning of discussion at the COSPAR level in 2 different bodies. One is the Planetary Protection Panel, and the other with John Rommel and others. And the other is the Exploration Panel, which is, I would say, led by Pascal Ehrenfreund. And people are discussing about how to adapt, or not to adapt, I would say, the planetary protection recommendation to this, to the manned exploration of the bodies.
Okay, thank you. I think that's all from Turku now.
Yes, hi, and thank you, Michel, for the interesting lecture. We have a couple of questions. Of course, this matter is very interesting, and there are a lot of aspects, economical, philosophical, and so on. And economical, my guess is that the scientists in that matter have something to say, because there is no perspective at the moment of economical exploitation, because if there is such perspective, then we know that even the presence of intelligent life doesn't stop people to try to get at resources. But to avoid all these kind of questions, I have a concrete question about the categorization of the mission, maybe because unfortunately I've lost the first part of the lecture. So my question is, how, in which category are, for instance, missions in which you have the possibility of indirect contamination? So a mission that is visiting a planetoid or a comet, and then it can be even not a return mission, but it can deposit on that celestial body some material, some organic material that could afterwards contaminate other planets when the comets or the meteorites falls on that planet.
There is 2 different things. The first is the categorization of a mission is depending on the target body, on the intention that you have, if you want to go around or to crash or to land, and on the science that you have on board, if you want to look for life or not. Let's say if you have an astrobiology payload or not. Then we have to consider, in any case, you are supposed to keep, I would say, a track of which organic materials you are sending there. If there are more than, I don't want to tell something wrong, but around more than 3 kilograms or something like that. And then you have to keep a coupon of these organic materials that you have sent elsewhere, to take them as samples if you need. To look at them if there is questions later. As far as I know, we don't consider the risk of sending a spacecraft on a comet, and then this comet could contaminate another body. I think that this was not considered for two reasons. The first is that the probability exists, but is quite remote. That's the first. And the second one is a crash of a celestial body on another body, in general, is really vaporizing almost everything, I would say. If they are big enough to have something on that. And in this case, I would say the contamination is not a real issue. Either by the time that we will wait to have this kind of thing, and then nothing is impossible. I recognize that is probably true, but it's difficult to imagine that you will sample exactly the place where you will crash, the place that you visited, I would say, 20 years ago. So I would say it's not considered as it's not a first order, even a second order, it's a third order, and it's not considered right now.
Mm-hmm. Okay, thank you for the answer. Now we have another question by Adam Watne. I'm giving him the floor.
So hello, thank you for your lecture too. And there is very robust method to work out the rules which protect another body from our forms of life. But what about non-carbon based life forms which could be brought from other body to the Earth? Are some rules which can protect us from, for example, silicon-based life forms also?
Right now, I would say, your neighbor can tell me if I'm wrong, but I would say most of the astrobiologists are really looking for carbon-based life. Mm-hmm. And I would say that there was an analysis by the Space Study Board, and you can go on this Space Study Board site, and you will see something about original form of life. This was a booklet which was issued, I would say, perhaps 8 years ago or something like that. And they make an analysis which is summarizing, I would say, the feeling, I would say, or the believing, I don't know, but the feeling of most of the astrobiologists that it's very, very difficult to imagine, at least in the solar system and probably in our galaxy, something that we could define or recognize as life, which is not based on carbon, for different reasons, and we can discuss that for, I would say, a long time. But this is difficult to imagine because of the reactivity of the silicon itself. About the fact that so the electronegativity of silicon make that is not very reactive, and with silicon you have a few. I would say most of the products are absolutely insoluble. So that means that you cannot have water as a solvent. And life without polar solvent like water seems difficult to conceive. Nothing is impossible, but I would say with the knowledge that people have in hand now, most of the astrobiologists, and would say the real scientists, I'm not a real scientist, but the real scientists are thinking that we cannot reasonably consider something other than carbon-based life.
Ah, thank you very much.
So I don't know what Franco is thinking about that.
Yes, of course, I agree. And so thanks a lot. We think that we have so we have a lot of questions, but of course, we thank you very much for the interesting lecture. Thank you. Bye.
Bye. Thank you.
Hi, everybody. So,
Hi.
I guess water. Can I make the question?
Yes, please go ahead.
Okay. I guess the water is one of the parameters you take in consideration in the classification of planetary protection. So how much the hypothetical presence of water on a planet is important to classify a planet or to make an hypothesis of an eventual life form on this planet?
First, we know all of us are knowing that water in general is widely spread in the universe and in the solar system. As soon as you have liquid water, people are thinking that you have some chance or few chance to find perhaps some life. And in any case, that there is a real risk of contamination with terrestrial organisms.
Okay.
Even it's not obvious because, and the main problem is, do we have water on the surface? And we don't know any place in the solar system where you have water at the surface, but liquid water, I would say, liquid water at the surface, but on Earth, which is not a problem for water contamination protection. And the question arises for mainly for Europa, for such as Titan, for I would say other icy satellites of the giant planets, and also for Pluton and Charon, because sometimes with the binary systems, you could have the same effect with Europa, this tidal effect, which is, I would say, keeping liquid layer somewhere under the ice. In this case, it's different, and people are thinking, and the COSPAR issued a few years ago, I think 2 years ago, a paper about the icy moon. And this will be taken in account in the future policy, and a new, I would say, new recommendation will be issued probably after the next COSPAR.